Good morning. Welcome to Lessons on Fluid Mechanics by Nilesh Vijay Sabnis. At the end of the unit, students will be able to define fluid and fluid mechanics, compare between fluids and solids, understand the properties of fluid. Let's define fluid. Fluid is a substance which deforms continuously under the action of shearing stress of any magnitude, and it has capacity to flow. It has no defined shape. Liquids and gases are coming under the fluid. Fluid mechanics is the branch of science which deals with the behavior of the fluid at rest as well as in the motion. At rest means static, in motion means kinematics and dynamics. Thus, fluid mechanics is the branch of science which deals with the statics, kinematics and dynamics aspects of the fluid. Let's discuss the applications. Design of a canal, levee and dam systems. Design of pumps, compressors and piping used in the water and air conditioning system of homes and businesses, as well as the piping system needed in chemical plants. The aerodynamics of automobile and supersonic aeroplanes. The development of many different flow measurement devices such as gas pump meters. Now pause the video and try to list out other applications of fluid mechanics that are used in day-to-day life. Hope you have listed out the examples are like blood is flowing through the veins and designs of ships, aeroplanes and various types of turbines are the examples. Now we will discuss the properties of fluid. Any characteristics of a system is called as a property. Properties may be intensive or extensive. Extensive properties per unit mass are called as a specific properties. First property is density or mass density, denoted by rho. Specific weight or weight density. Specific volume. Specific gravity or relative density. Viscosity. Density is defined as mass per unit volume. Rho is equal to mass upon volume. Specific volume is defined as reciprocal of density, that is volume upon mass. The specific weight is defined as the weight per unit volume. The specific gravity or relative density is defined as the ratio of density of a substance to the density of some standard substance at specific temperature. Viscosity is the property that represents the internal resistance of fluid to motion. It is a property of fluid which offers the resistance to the movement of one layer of a fluid over another adjacent layer of the fluid. Some fluids are more viscous, some fluids are less viscous. Up till now, we have seen different properties of fluid. Now see the types of fluid. Fluids are classified into two groups, real fluid and ideal fluid. Again, real fluid is further classified into Newtonian fluid and non-Newtonian fluid. And non-Newtonian fluid is classified into four groups, ideal plastic, real plastic, shear thickening and shear thinning. Ideal fluid is incompressible fluid with no viscosity and it is imaginary. The fluids with viscosity are real fluid. All the fluids existing are real fluids. Newtonian fluid are the more common fluids, such as water, air. If fluid is Newtonian, it should follow the Newton's law of viscosity. That is, shear stress is directly proportional to rate of shear strain. If the shear stress is not directly proportional to rate of shear strain, it is called as a non-Newtonian fluid. In case of shear thinning, viscosity decreases with the increase of the shear stress. Harder the fluid is sheared, the less viscous it becomes. Example is latex paint does not drop from the brush, but while painting, it flows smoothly over the wall. Shear thickening. Viscosity increases with the increase in the shear stress. The harder the fluid is sheared, more viscous it becomes. Water corn starch mixture is the best example. Now discuss next property is the surface tension. Many of us would have seen the demonstration of a needle being supported on water surface without it being weighted. This is due to surface tension of the water. Surface tension may also be defined as work in Newton meter per meter square or Newton per meter required to create unit surface of a liquid. The work is actually required for pulling up the molecules with lower energy from the below to form the surface. Another definition of a surface tension is the force required to keep unit length of a surface film in equilibrium. The formation of bubble, droplets and free jets are due to the surface tension of a liquid. Here we can see how the molecules on the topmost layer of a fluid are facing the downward pull, and due to that surface tension is occurring. These are some examples of fluid surface tension. Insect can walk over the water and leaves are not sinking in the water. Thank you for listening.